Organic fertilizer, such as compost or manure, is made from natural sources and therefore contains less chemicals that are potentially harmful to the environment. Since some gardeners are also concerned with the growth rate of plants, we are testing if either type of fertilizer, organic or non-organic, is more effective in the speed of mung bean growth. We planted all of the mung bean seeds in plastic cups using paper towels, water, and either organic or non-organic plant fertilizer. To randomize our experiment, we gave each seed a number. The odd-numbered seeds were placed in the organic fertilizer group, and the even-numbered seeds were placed in the non-organic fertilizer group. We used a calculator to generate random numbers until we got enough seeds for our sample. We planted 10 mung bean seeds in each of 2 cups. After 4 days, we added organic fertilizer to 1 cup and non-organic fertilizer to the other cup after measuring the lengths of each sprout so far. We then waited 3 more days and measured the lengths of all sprouts. We calculated the differences between sprout lengths before and after fertilizer and found the standard deviations. The standard deviation for organic fertilizer was about 1.477 centimeters, and the standard deviation for non-organic fertilizer was about 0.616 centimeters. We used a margin of error of 0.4 and used the margin of error formula to find our sample sizes. Our sample size for organically fertilized beans is 54, and our sample size for non-organically fertilized beans is 12. To minimize the influence of other variables, we planted all the seeds in the same area and gave each the same amount of water and sunlight. They were all in an area of the same temperature. We randomly selected 54 seeds to be planted with organic fertilizer and 12 seeds to be planted with non-organic fertilizer. We waited 4 days for the beans to sprout, and then we measured the lengths before adding fertilizer. We waited 3 more days before measuring them again. We then calculated the differences in length before and after we added fertilizer and found the means and standard deviations. The mean for the organically fertilized seeds was 1.448 centimeters, and the standard deviation was 0.436 centimeters. The mean for non-organically fertilized seeds was 2.542 centimeters, and the standard deviation was 1.244 centimeters. First, we checked conditions. We randomized the experiment, so we satisfied the independence assumption. The groups were independent of each other. The histograms of the 2 groups of data are roughly unimodal and symmetric, so we satisfied the nearly normal condition. All of the conditions and assumptions were satisfied, so it was okay to use a student's t-model for a 2-sample t-test for the difference in means with alpha equal to 0.025. Our null hypothesis is that there is no difference in mean heights of mung bean sprouts after 3 days between organically fertilized and non-organically fertilized groups. Our alternative hypothesis is that there is a difference in the mean heights of mung bean sprouts after 3 days between organically fertilized and non-organically fertilized groups. After running the test, we found a p-value of 0.0114. Since this is less than our significance level of 0.025, we reject the null hypothesis. There is sufficient evidence of a difference in mean heights for mung bean sprouts using organic and non-organic fertilizer after 3 days. We then performed a 2-sample t-interval for the difference in means. The conditions and assumptions were already satisfied, so we proceeded. We can be 95% confident that the mean height for mung bean sprouts planted with non-organic fertilizer is between 0.297 and 1.89 centimeters greater than the mean height for mung bean sprouts planted with organic fertilizer after 3 days. Although organic fertilizer is said to be healthier for plants over time, it appears as though non-organic fertilizer increases their growth rate, although we would need to perform many more experiments to be sure of this.